welcome Thibault Sorret. Hi Thibault, we're happy to have you here. So, you're the founder and CEO of Wildsense. You are currently finishing a Master of Science degree in Biodiversity, Wildlife, and Ecosystem Health with the University of Edinburgh, right? So, prior to studying Wildsense, you lived in Montreal, Canada, where you worked as a chief of staff uh, at Loufa Farms and studied commerce at McGill University. And your main focus is on biodiversity. And today you are going to present to your work to us.
Exactly. Can you hear me okay?
Yeah.
Fantastic. So today I'm going to present Wildsense, a short little presentation. Can you go to the next slide, please? The basic premise is that forests are facing enormous amounts of threats from storms, fire, insect outbreaks as a result of climate change. Not only are the temperatures already changing quite a bit across Europe and the continental US, but the risks associated to forest ecosystems are increasing massively as well. People talk a lot about fire, especially in California. What's interesting, and we'll get to it, is these other risk factors, storms and insect outbreaks, are very much linked to end effects that are sort of sexier, like fire, and get more media attention. But the upstream causes of these large-scale fires don't always get talked about as much. Next slide, please. So insect outbreaks in particular cost forester 15 billion euros a year and affect over 85 million hectares around the world each year. For the people in France, the entire surface of France is about 65 million hectares. So an area bigger than the size of France each year gets devastated by insect outbreaks. These insect outbreaks in terms of surface area affect more land each year than fire does. It's an enormous problem that's heavily under-mediatized. Next slide, please. Now, bark beetles are tiny little insects. They're usually the size of a grain of rice. They're not particularly cute. And they're called secondary parasites. Typically, under normal conditions, they attack wood that's already weakened, already dead. And so in a healthy ecosystem that's functioning normally, that's at an equilibrium, they're a natural part of the cycle. They're going to attack dead or weakened trees and help recycle nutrients, for example. Now, there are about 600 species of bark beetles, and they work in slightly different ways, but roughly speaking, they will go into a weak tree, dig underneath the bark, dig little tunnels, have their offspring in those little tunnels, which will then feed on the phlegm, so on the flesh, if you will, of the tree in order to gain strength and then come out and go attack other trees. The main source of population growth, I'll go back 1 second there. The main source of population growth for them occurs during extreme events like large storms. When you have a large storm, you have a lot of wind throw. So you have a lot of trees that fall down as a result of the storm. And that leads to a lot of supply of food for these populations. And so they're able to expand quite a bit. Same with drought-stressed areas, California being one of them. These drought-stressed areas create much more easily attackable food sources for these bark beetles to create nurseries in and for their populations to grow. Now, when their population grows, next slide, please, this happens. This is a problem. So this is just entire forest that I believe this one is in Verdun in France, not in North America, but this is hundreds and hundreds of hectares of forest that are just dead. And the reason is when the populations reach a high enough density, they're able to attack healthy trees. So you have a tipping point. At a certain point, if there's a critical mass, they go from attacking weakened trees to being able to attack any trees, because these tiny little insects will gang up on a given tree. And if enough of them are available to attack a tree, even if it's healthy, they will be able to kill it. In North America, this is since 2018, I believe, they've killed about 100,000 square miles of forest in Western North America. And that's just the mountain pine beetle, just one species. This is absolutely enormous amount of impact. Next slide, please. And when that happens, you get a lot of kindling for enormous fires. So if you look at sort of the whole chain, you've got drought that's weakening the trees. Then you've got insects that are going and attacking the weakened trees. Their population is growing enormously. Their population is then able to attack healthy trees. They then devastate, say in the case of California, between 2012 and 2017, they can devastate 150 million trees, which are dry firewood, essentially, that's just standing there. And as soon as a fire starts, you've got an enormous amount of very dry wood that burns up very, very, very quickly. Important thing to note, 90% of what burned during the Creek Fire was timber that was killed by bark beetle. It was very, very dry wood, and so it lit up and spread very, very quickly. Next slide, please. So how do we fight these bark beetle attacks? Well, number one thing we can do is cut out trees that take out the dead trees, and try to do so early enough that we can get them before the new generation goes and attacks other trees. You can also use pheromone traps. So pheromones and pheromones are scents that insects use to communicate. So we can lure bark beetles into traps to avoid them spreading to other trees. This works, but only to a certain extent, which is why sanitary cuts of trees that have been affected already are very important. And the last part is early detection. The earlier we detect these insects, the more we prevent their spread, and the more we prevent outbreaks before it reaches these tipping points. Next slide, please. So what we do is pretty simple. We monitor forest health through satellite imagery. We're eventually going to look at multiple sources of risk. For the time being, we're focusing on bark beetle attacks. And so we use satellite imagery, specifically the infrared and near infrared bands on multispectral imagery from a satellite called Sentinel-2, which is a European agency, space agency mission. So we get this data mostly in the infrared, shortwave infrared, near infrared sectors, and we're able to detect trees that have been affected by these insects using the satellite imagery and create a map essentially of the areas at risk or that have been attacked. Next slide, please. So how does it work? We download the satellite imagery. We run our model that we built in-house to detect these insects. We map out the risks, send them to foresters. Foresters go out in the field, check if they're accurate, and then decide whether or not to perform a sanitary harvest in order to move those trees out before the insects can spread to other trees. Next slide, please. A quick case study. So this is in Burgundy. You can see here in 2020, only in red are where the bark beetles are. There's very, very few spots that have been affected. You can see on the very bottom of your screen there for the May area, you've got an area that isn't present in August, and same at the very top of your screen there. So there's a few areas that they identified and were able to cut. The problem is towards sort of there's a relatively large area bottom of the May screen that was left alone. And so that area spread enormously. These insects can travel several kilometers away in search of weakened trees. By leaving this area as it was, the insects are still able to spread quite a bit between May and August 2020. You can also see here all of the white sort of sections within the red lines. That's clear-cut forests from years 2018 to 2020. So this forest is about 200 hectares. They've already lost about a third of their land due to this problem. And they keep being attacked because they're unable to monitor and see these insects early enough. Next slide, please. So we built a team, went out to try to fix this. We're still in the initial stages. We've got 16,000 hectares that we're working on. Next slide, please. And now we're looking for pilot projects in America. We've got projects in France, in Germany, in Austria. We're expanding to the rest of Europe, but we would definitely love to do some work in North America if possible.
Thank you so much, Thibault. And it has been 10 minutes. This is perfect timing. I think you have a question in the chat for you.
Yeah, I just saw that from Julien.
Very tiny because we're running out of time. Tiny.
Perfect. Do we have any international competition? Short answer, there are a few competitors using drones, but it costs 10 times as much because I mean, they have to actually run the drones. We just use satellite imagery. In terms of satellite imagery, not much competition there. We want to move to other to other problems in forests. So if you have a forest in mind and a problem that we can try to tackle, definitely let us know, and we'd love to look at it. We are based in, for Sharon, we are based in Paris, but we work all over the world. The satellite imagery is anywhere around the world, so we can do work anywhere.